For this equation, we need to solve cosine of theta is equal to 0.28. This value cannot be expressed by one of the special triangles, but we can still find the answer, and we'll use decimal approximations for this one. First, we need to look at the sign. So in this case, cosine is positive. And we need to find the reference angle for both of those angles. Since this does not represent a special triangle, I'm not going to draw the triangles. Instead, I'm going to write this in inverse form and use the calculator to find the reference angle. When using the calculator, you want to make sure that it's in the correct mode, either degree or radian. Once the calculator is in radians, then you can plug in using the inverse function, cosine inverse, and in this case our value was 0.28. So here we need to approximate. I'll approximate this one as 1.29, and that's our reference angle. And the way that we can find the measure for the actual angles is the same thing that we would do even if we had it as a special triangle. The first angle is in quadrant 1, which means the reference angle is the answer. The other angle is in quadrant 4, and to find that we could do 2 pi minus our reference angle of 1.29. And I'll plug this into the calculator to get the decimal approximation. I'll round this angle to 2 decimals as well, and so the second angle can be expressed as 4.99 radians. Once we have the two solutions on the interval 0 to 2 pi, we can also find all solutions. Since our original answers are not exact, they're approximations, these all solutions are going to be approximations as well, but we can express them as 1.29 plus 2 pi k and 4.99 plus 2 pi k. Here we have another equation where we won't be able to use a special triangle in order to solve it, but we can use the calculator. I do want to mention a few things about inverse functions. If we look at inverse functions, in order for a trig function to have an inverse, it needs to be restricted to a certain domain. And for the cosine function, well, actually for all of them, what that means is you want to select a domain that includes one positive quadrant and one negative quadrant. For the cosine, that means that the inverse function would be defined between 0 and pi. The restricted domain for tangent is a little bit different, even though it is negative in quadrant 2. And now to find the reference angle, I'll plug this into the calculator. Again, since we're dealing with radians, you want to make sure that your calculator is in radian mode. And plug in tangent inverse of negative 10. So here we actually get a negative value, which means rotating in the clockwise direction. This is the case because tangent inverse is defined between negative 90 degrees and positive 90 degrees, or negative pi over 2 and pi over 2. So whenever you have a tangent inverse and plugging in a negative value, the result will always be a negative angle measure. What you want to keep in mind, though, is that this is still the same thing as our reference angle. So we actually found that our reference angle is 1.47. While we have found a solution, we need to find the answers on the interval from 0 to 2 pi, which means we need the two positive answers. So we can use this reference angle to find the two positive angles. To find the first angle, we would do pi minus 1.47. And to find the second angle, we would do 2 pi minus 1.47. For the second angle measure, we're essentially finding an angle that's coterminal to the negative 1.47. And to find coterminal angles, you either add or subtract 2 pi. So if you take negative 1.47 and add a full rotation of 2 pi, you get to the exact same answer, which is 4.81. To find all solutions, we can take each answer and add 2 pi k. But since this is a tangent function and the two angles are along the same line, we can condense this solution. We can condense the solution and write it as 1.67 plus pi k.